Welcome to Shanti-Peace for Mathematics. In this video, we'll talking about Pfaffian differential equation and how to solve a Pfaffian differential equation. So first of all, you should know what you mean by a Pfaffian differential equation. A Pfaffian differential equation f1 dx1 plus f2 dx2 up to fn dxn equal to 0. So this f1, f2 up to fn are continuous functions of the variable x1, x2 up to xn. And this expression is known as a Pfaffian differential equation. We'll define this x bar as f1, f2 up to fn, and the x bar dot curl of x bar is 0. Then the Pfaffian differential equation is integrable. Integrable means we can able to find out its solution. So this is the if and only if condition to check whether the given Pfaffian differential equation is integrable or not. And if it is integrable, we can able to find out some integrating factor and all sort of things is there. So here we are talking about some examples based on this. So this is the first example that I am taking so that the following Pfaffian differential equation is integrable. So all the examples we are dealing here, it is for 3 variable only. And here the question is to find out whether this Pfaffian differential equation is integrable. That means it is solvable or not. If it is so, we need to find out what is the solution for that. So if you compare with the previous expression, that is f1 dx plus f2 dx2 dy plus f3 dx3, here it is z equal to 0. We'll have here f1 is equal to y, f2 is x, and f3 is 2z. So your x bar here, x bar is y, x and 2z. We need to check whether the x bar dot curl of x bar is 0 or not. So first of all, we need to calculate what is the curl of x bar. So to calculate the curl of x bar, we know that it is of the form ijk, del by del x, del by del y, del by del z, and it is f1, that is y, x and 2z is there, y, x and 2z is there. So this have the 3 components, del by del y of 2z, so that is 0, minus del by del z of, that means the partial derivative of x with respect to z. So this is the operation that we are doing. So that will also gives me 0. Here we do this, that is del by del x of 2z, which is 0, del by del z of 2y, sorry, of y, it is also 0. The last one is del by del x, so it is 1 minus 1 in the last. So finally this is a 0 vector. So the curl of x bar is a 0 vector. X bar dot curl of x bar, since this curl of x bar is 0, so it is x bar dot 0 is there, and the dot product of any vector with the 0 vector will give you a 0 answer. So that means we can say that the given equation is integrable or it is a solvable. Now let me write down what is that equation is. The equation is written in the form of y dx plus x dy plus 2z dz is equal to 0. Now you just observe the first 2 quantity here. So the derivative y as it is a derivative of x, x as it is a derivative of y is there. So this quantity I can write down as dy plus 2z dz. So if I take just directly take the integration here, so if I take the integration here, that will gives me a integration of 1 with respect to xy. So that will gives me xy, and the integration of 2z with respect to z, that is 2z square by 2. is equal to some constant c is there. So finally the answer is xy plus z square is equal to constant is the final or a solution for this Pfaffian differential equation. This is the one way to looking at the solution. Directly solution is there. But every differential equation, every Pfaffian differential equation cannot be solved in this manner. So I am talking here is the general method to solve this Pfaffian differential equation. So for that we'll have certain steps here to see. So this is the step number 1. In that we will consider the Pfaffian differential equation is of this form. So we are talking about the Pfaffian differential equation with the 3 variable only. So we'll have, this is the equation that is PQR. So P dx Qy R dz is equal to 0 is the Pfaffian differential equation is given. So we consider this x bar is equal to PQR. The step number 1 is to verify whether the given Pfaffian differential equation is a solvable or it is integrable or not. So as we have talked in the previous example also, the condition is to check whether this x bar dot curl of x bar is 0. So first step is to check whether this x bar dot curl of x bar is 0 or not. Next step, that is a step number 2, which tells you that you have to treat your variable, any one of the variable, let's say z as a constant, and that is dz is equal to 0. So in the equation p dx plus q dy plus r dz equal to 0 is there, you have to substitute z is a constant, so dz is 0. So the equation represent or reduce into the p dx plus q dy, that is we have here. And this is very crucial step actually, because every time it is not necessary that always you have to choose your z is equal to 0. It depends on the differential equation, in which situation we have to consider which variable treated as a constant. So we should select the proper variable to be a constant, so the resulting equation remain the variables is easily integrable. So we have to select such a way that this equation that we have here, it should be integrable. Thus this selection is vary from problem to problem. So if you have different equation, then you will have a different variable you have to treat as a constant. This representation, that means whatever the discussion I am doing here for the steps is I did for z is equal to constant, and for the other cases you have to do the necessary changes and made it in the entire problem. Now the next step number 3. So in the step 3 we need to find out what is the solution of this equation p dx plus q dy equal to 0. And the solution of this one will represent as, it is in the variable u of xy, and there is a constant is that, but that constant is a function of z we can consider, where f of z is an arbitrary function. So only unknown thing is now it is f of z. Note that in place of taking absolute constant, we have f of z is a possible, because it is arbitrary constant is a constant, and it may be a respect to the x and y. So this keeping without sharing assumptions that merely that as z is equal to constant. So the solution of this one, it is of this form that we can have. The step number 4 and 5. The step number 4 and 5, the fourth one is, you have this equation now. So u dx is equal to f of xyz totally with respect to xyz, and compare with the result is given in the equation. After comparing, that means you have to compare the equations. We shall get the equation in the 2 variable only, that is f of z and dz. So we have to substitute the value here, and then the whole equation is converted into 2 variable only, f and z only. The coefficient of df and dz involve the function of x and y, and which is always possible to remove using this. And then we need to solve whatever the remaining equation is there, we need to solve that from the equation 4. and we have the value of now f of z, we shall get the required solution into that form. Let us see via an example and see how this will work. So this is the first equation we can consider. So here the value of p, you can say that it is yz, value of q it is 2xz, and value of r is minus 3xy. By comparing, the equation p dx plus q dy plus r dz equal to 0, we get this. So you have to check whether the x bar dot curl of x bar is 0 or not. So first I will calculate what is curl of x bar. So that is ijk del by del x, del by del y, del by del z, yz, 2xz minus 3xy. So if you differentiate this, or if you expand this determinant, the derivative of this one with respect to y according to this rule is be applied. So you will have minus 3x is the answer. The differentiation of this one with respect to z will gives me 2x, so it will be minus 2x. Then in the next step you will have this and this. So the differentiation of this with respect to x, so you will have minus 3y, but already minus sign is there due to the middle term, and del by del z of that thing, that means the derivative of this with respect to z will gives me y, so that's why it is minus y. The last term that we have, this rule is applied. So the derivative of this with respect to z, sorry x, so it will gives me 2z, minus derivative of this with respect to y will gives me z. So the final answer for this quantity is minus 5x. This is minus 4y, but minus minus plus, so it is plus 4y, and this will be z. What is curl of x bar into? So it is x bar dot curl of x bar. The x bar is yz 2xz minus 3xy. Dot product with what we got, it is 5x minus 5x 4yz minus 5x 4yz. So this will gives me minus 5xyz plus 4 to the 8 xyz minus 3xyz. So this will gives me 0. So therefore the given equation is integrable. So this is our step number 1 is over. Now in the step 2, what you have to do, we have to consider some variable as a constant. So I am taking z is equal to constant. If z is constant, dz will be 0. So the given equation reduced to the equation that is yz dx plus 2xz dy equal to 0, in which this z is also constant. So I am putting the value of z also there. So previously we have considered z is constant, let's say z is c1. So that will gives me 2c1, sorry, y. So therefore it is this c1y dx plus 2x c1 dy equal to 0. So finally this will gives me y dx plus 2x dy equal to 0. Now we have to solve this equation. So solving this equation, what we get, it is this, that is, I am dividing both the equation by xy, or you just do the separable variable method. Okay, so this is y dx is equal to minus 2x dy. So that's why it is 1 upon x is equal to minus 2 upon y dy. So therefore this will be log x minus minus, if we can go to this side, it is log y square is equal to constant, but that constant I need to take as a function of z. So let's say this is C2, but the C2 is a function of z, and this will simplify as x y square is equal to some constant. So this is the equation is u of xy is equal to some constant c, where u of xy is xy square. So we have now xy square is equal to some function f of z, let's say, because this constant is a function of z. Now differentiating this, we get, so product rule will apply. So y square as it is, the derivative of x is a dx, plus 2y x as it is, the derivative of 2y it is y square, it is 2y dy, minus, if I take this one on the other side, is f dash of z dz is equal to 0. Now if I call this as the equation 1 or 2, and the given equation we will have equation 1 is this. You just see that this something is missing here, it is y square. So given, let me write the given equation here. Given equation is yz dx plus 2xz dy minus 3xy dz is equal to 0. This is my equation number 1, I call. Now how to reduce, or I need to have this quantities should be equal. So I need to divide and multiply something to get this to equality set. So just see that this y is extra here and z is missing. So I have just divided this equation 2 by z by y. So dividing equation 2 by z by y, we get exactly the same thing. Yz dx plus, just divide that z by y, that is 2xz upon this y will get cancelled y. So it is 2xz dy, that is minus z by y f dash of z dz. So it is z by y f dash of z dz is equal to 0. If I call this as equation 3, comparing 3 and 1, will get, the first quantity is same, second quantity is also same. So we will have minus z by y f dash of z is equal to minus 3xy. And if you can just see that this is will be f dash of z is equal to 3xy square by z, and we always able to convert this in terms of f of z. So this is 3 because you saw that f of z is xy square. So this is 3 xy square is f of z upon z. So this equation, it is in terms of f of z and z, as it is in the step 4 it says. This is always reduced into the form of f of z and z. So finally what we have, it is f dash of z upon f of z is equal to 3 by z. So if you use the separable variable method to do this, so it is df by f is equal to 3 by z dz. This is f dash is df by dz, I can say. This is the derivative of f with respect to, so if you substitute, you will have this. Now if you integrate both sides, therefore it will gives me ln of f is equal to 3 ln of z plus some constant is there. Let's say that constant is C3, ln of C3. So that's why it is f is equal to z raised to 3 into C3. But what is the value of f you have? The value of f we have got, that is f xy square. We'll substitute that value here. So it is xy square is equal to z cube into C3 is your final answer. That is the solution of a given differential equation. Let us try to solve another example. That is this: 3x square dx 3y square dy minus x cube plus y cube plus 2 e raised to 2z dz equation. So comparing with PDX plus Q dy R dz equal to 0, we get P equal to 3x square, Q equal to 3y square, R is equal to x cube plus y cube plus e power 2z minus. So first we need to calculate what is the curl of x bar, because we need to check whether the curl of x bar into x bar is 0 or not. That is true for integrability. That is ijk del by del x, del by del y, del by del z. 3x square, 3y square minus of x cube plus y cube plus e power 2z. So now we'll do this cross or expanding this determinant. So derivative of this with respect to y will gives me 3y square, and it is of minus sign. A derivative of this with respect to z will gives me 0. In the second term you will have this and this one. So the first is a derivative of this with respect to x will gives me minus is already there and minus 3x square. Then again minus. A derivative of this with respect to z will be gives me 0. The last one that we have, this two cross products. So the derivative of 3y square with respect to x will gives me 0, and the derivative of 3x square with respect to y will gives me 0. So finally your answer for this curl of x bar is minus 3y square plus 3x square 0. So hence x bar dot curl of x bar, the x bar we have, it is 3x square, 3y square minus x cube plus y cube plus 3 e power 2z dot product with minus 3y square, 3x square 0, minus 3y square, 3x square 0, and hence this is minus 3x square y square plus 3x square y square and plus 0. So that will gives me 0. So therefore the given equation is integrable. So the first task is to do is, let us take z be treated as a constant. So we have dz is equal to 0. So if I call this equation, first equation as 1, then the equation 1 will become 3x square dx plus 3y square dy equal to 0. And if you integrate this one, that will gives me 3x cube by 3 plus 3y cube by 3 plus some constant, but that constant is in terms of z, because z we have taken as a constant. So I'll say that is f of z, where z is constant. So that will gives me x cube plus y cube is equal to f of z. Let's say this. Differentiating equation 2, we get 3x square dx plus 3y square dy minus f of z, f dash of z dz equal to 0. If I call this is as equation number 3. Now if you compare the 3 and the equation 1, so comparing 3 and 1, we get. So just say that in equation 1 we have 3x square, 3y square here. So that two things is already there. The third one is not there, that is f dash of z, minus f dash of z. We'll have minus f dash of z. On the other side we'll have, it is minus x cube plus y cube plus e power 2z. So it will have x cube plus y cube plus e power 2z, but it is of negative sign. So here you will have a negative. So finally you will have f dash of z is x cube plus y cube plus e power 2z. But this value we can able to write down in terms of f of z, that is x cube plus y cube is f of z. So that's why this is, you will have f of z plus e power 2z. Now we need to solve this differential equation. This is df by dz. So this is a linear differential equation that you can say in the first order. And we know that to solve this linear, so it is of the form dy by dx plus p dy is equal to q. And the integrating factor to find out this one is e power p dx. That is the integrating factor. So here the integrating factor is e power s. If you can see by comparing this one, p is minus 1 dx dz, because z is a variable. So that's why this is equal to e power minus z. This is the integrating factor. And if this is the equation, then the solution can be written as y into integrating factor is equal to integration q into integrating factor dx plus constant. So this is the way is to write down the solution. So here your y, that is the function f. So it is f into integrating factor is what e raised to minus z is equal to a value of q is e power 2z. So that's why it is e power 2z into e power z dz plus some constant dz. This is minus z. So this will gives me e power z dz plus c. So finally f e power minus z will gives me e power z plus constant c. So the function f of z you will have is e power 2z plus c into e power z. And the value of f of z we have obtained it, that is x cube plus y cube. So the final solution you will have it is x cube plus y cube is equal to e power 2z plus c e power z. This is the final answer or final solution for the given differential equation. Let us solve one more example. Is this, that is 2x square plus 2y xy plus 2xz square plus 1 dx dy plus 2z equal to 0. First we need to verify whether this given differential equation is integrable or not. That I am giving you as a homework. Here x bar is 2x square plus 2xy plus 2xz plus 1 and 2z. So I'll just say that, check that x bar dot curl of x bar is 0. That I am giving you as a homework. You can do it, you can try for yourself and try to find out the x bar dot curl of x bar is 0. And it is there. I have checked that. Now next one is to treated one variable as a constant. But by some calculation I found that if I put z is equal to constant, then it will not work out. So you have to choose another variable which is as a constant. So I am putting x is equal to constant. To put x is equal to constant, dx will become 0. So the equation 1 become y plus 2z dz is equal to 0. Integrating both sides, we'll have y plus z square equal to some constant, but that constant it is in function of x, because here x is constant, so it is function of x. Let's say this is the function you have. Now differentiating both sides, we get dy plus 2z dz equal to f dash of x dx. Now if you compare the previous equation, that is this, if I can say this is equation number 2, comparing 1 and 2, we get, you just see that in the previously the equation 1 is this, the coefficient of x is this one, the coefficient of y is 1, here the coefficient of y is 1, the coefficient of z is also 2z, so here is also 2z, so we have f dash of x is equal to 2x square plus 2xy plus 2xz square plus 1 we have. Now we need to adjust here somewhere, we need to pick our function f of z. The f of z function is this, y plus z square. So we need to look at y plus z square is here also there. So this I may separate into this form, that is, so it will be minus of this. So minus of f dash of z is 2x square plus 1, and from this 2 you just see that x is common out, 2x is common out, so you will have y plus z square, and hence this value you can write down as f of z. So finally you will have minus f dash of x is equal to 2x square plus 1 plus 2x into f of x. So you will have this equation can be written as df by dx plus 2x fx is equal to, this minus sign will go on the other side, that is minus of 2x square plus 1. This is also a linear equation in one variable. So the integrating factor is this, so you compare with dy by dx plus p dy is equal to q, then the p is 2x here and q is this value. So therefore the integrating factor is integration p dx, which will gives me integration 2x dx and will gives me e power x square is integrating factor. Therefore the solution is y, that is f of z, f of x into integrating factor, that is e power x square, equal to integration q. The value of q you will have a minus of 2x square plus 1, so it is minus of 2x square plus 1 e power x square. So this will be 2x square e power x square dx plus integration of e power x square dx. Okay, so to solve this one, we'll apply some technique here. So let me integrate this one separately. So we have, this is 2x square e power x square dx. This I can write down as 2 outside x into e power x square dx. Now I will apply the integration by parts for this one, this function. This one x as it is, then integration of 2x e power x square dx, then it is minus a derivative of x which is 1, and the integration of this quantity, that is integration 2x e power x square dx, and whole integration is there. Now what will be the integration of this quantity, that is x, 2x e power x square. As you know that it is e power some function f of t into d, f dash of t dt is there. then the integration of this quantity is e power f of t plus some constant. Why? If you take this f of t is equal to some variable y, then the dy is equal to f dash of t dt. We substitute that, you will give me e power y dy integration. The integration of e power y is e power y, so that's why it is y is equal to f of t. So that is the answer you will have. So the integration of this one, so derivative of x square is 2x, which is here. So the integration of whole this thing is x into e power x square. Here is also minus integration e power x square dx is there. So the integration of this quantity is this much. And previously, if we substitute that value here, then that will leads to fx into e power x square is equal to minus of x e power x square minus e power x square dx, and here is plus e power x square dx, and this will get cancelled. So finally the answer is left is this, that is f of x e power x square equal to minus of x into e power x square, and the value of f of x which we have got from previously, the value of f of x is x plus y square. So we substitute here, that is y plus z square is the value of f of z, e power x square equal to minus x e power x square plus some constant c. So that's it, is the answer. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you in the next video. Till then, bye bye, sayonara.